OMO-1 is a skeleton that rewrote the story of human origins, a find so significant it promised to anchor the timeline of our species' emergence in Africa. However, the very foundation of that discovery, whether the fossil was found in situ, which means buried in its original context, or merely as a surface find, is shrouded in conflicting accounts. This is the perplexing case of OMO-1, the earliest known anatomically modern human skeleton, unearthed near Ethiopia's Omo River in 1967. The discrepancy in its discovery context, coupled with a tangled web of dating controversies, raises critical questions about its age and authenticity. Could these inconsistencies undermine the fossil's role as a cornerstone of the out-of-Africa theory? Let's dive into the heart of this archaeological controversy, starting with the contentious issue of its in situ status and the implications for dating accuracy. This is not some fringe theory or some attempt to debunk the out-of-Africa theory by a conspiracy theorist. These questions have been asked by mainstream archaeologists since the fossil was discovered in 1967, including archaeologists who were on the same expedition and worked with the fossil. Unfortunately, in today's academic climate, you cannot raise questions about the out-of-Africa theory, so this responsibility falls to independent researchers. The story of OMO-1 begins with its discovery by Kamoya Kimeu, a skilled Kenyan fossil hunter working under Richard Leakey's direction during the 1967 Omo research expedition. Yet the narrative splits almost immediately. Carl Butzer, a geologist from the University of Chicago who was with the expedition, described OMO-1 as a surface find, suggesting it was exposed on the ground. Richard Leakey, however, labelled it partially in situ, implying some parts remained embedded while others were surface exposed. This fact is not a minor detail, it is of vital importance. Meanwhile, a study by Chris Stringer from 2008, misleadingly titled Confirmation of a Late Middle Pleistocene Age for the Omo Kibish-1 Cranium by Direct Uranium Series Dating, asserted that OMO-1 was found in situ, fully preserved in its stratigraphic layer. But Stringer's study did not confirm anything. In fact, they used the same dubious dating method to directly date the fossil as was used to date the shells. The study misleadingly claimed the fossil was found in situ when all evidence suggests it was not found in situ, but on the surface. In a study by John Flegel and associates also in 2008, they noted that, according to the original description, excavation of the site yielded some material in situ and established the provenance of the OMO-1 skeleton in terms of the stratigraphy of the Kibish deposits. Both the cranial remains and the postcranial remains have been considered by virtually all researchers to represent anatomically modern Homo sapiens. Flegel continues that, in the same year as the original description, papers describing the geology of the Kibish Formation and the hominid sites, including a series of radiometric dates, were published by Butzer and Thurber. They note that Leakey had received a test result of 130,000 years from a single shell, using thorium-uranium dating. However, in the paper, the authors noted that the accuracy of ages calculated from thorium-uranium ratios is difficult to determine, and perhaps impossible, even with much more detailed work. The age reported here should not be considered too seriously as an age, they warned. In his 1969 report, Butzer wrote that the 130,000-year age came from a personal communication with Leakey. The lab number for Leakey's shell is noted as L1303J, which suggests the skull was dated at a lab called the Lamont Laboratory, where Thurber worked. Thus, it is interesting that Thurber apparently did not want that 130,000-year age to be credited to him, and he did not include the test with the results of the carbon-14 dating of the other shells.
There were people who were saying, this stuff's probably 20 or 30,000 years old. There was an old date that said it was perhaps as much as 100,000 years old.
Beyond these problems, the dating of OMO-1 reveals another layer of controversy. Butzer reported carbon-14 dates ranging from 5,000 to 9,000 years BP for the Kibish Formation, reflecting lake-level changes rather than the fossil's age. These dates, derived from freshwater shells, align with a much younger geological period, suggesting recent sedimentation unrelated to OMO-1. These doubts over the actual age of the Kibish fossils were echoed by subsequent reviews of the material for several decades. In a review of African hominids in 1978, Frank Howell, who was the co-leader of the 1967 expedition with Leakey, noted, "Human cranial remains and some associated post-crania were recovered from a situation considered to represent the lower part of the Kibish Formation in southwestern Ethiopia. This unit of the Kibish Formation was accumulated when Lake Turkana stood some 60 meters higher than its present level and flooded the whole of the lower Omo Valley." Howells continued, "An age as old as 130,000 years has been suggested for the specimens on the basis of thorium-uranium measurements. However, the reliability of this method has still to be adequately demonstrated. Even if this determination appears reasonable, it is nonetheless unconfirmed. The radiocarbon determinations on shells from overlying members, with a minimum age 37,000 years, have also been questioned. The mammal fauna associated with one of the specimens, with few species represented, and none of them extinct, is frankly unhelpful, and also unconvincing of any very remote antiquity." This is a stunning critique by a well-respected anthropologist who was a co-leader of the expedition. This trio of conflicting descriptions, surface find, partially in situ, and fully in situ, creates a foundational problem for dating the fossil accurately. Why do these accounts diverge, and what does this mean for the reliability of OMO-1's age? The term partially in situ is particularly ambiguous. In archaeological terms, in situ means a find remains in its original depositional context, allowing geologists to date surrounding sediments or associated materials with confidence. A surface find, conversely, lacks this context, as erosion, water flow, or human activity could have moved it, rendering soil-based dating unreliable. Partially in situ suggests a hybrid state. Some elements of the skeleton might have been under the surface, while others lay exposed. But which parts of the skeleton? Without detailed documentation, it's impossible to determine. The original study notes the skeleton was found near a small hill's base, with a step trench dug afterward, but it offers no clarity on what was truly embedded versus scattered. This lack of specificity fuels speculation. Was the pelvis a key diagnostic feature in situ, or was it a surface find, potentially mixing it with younger material? When archaeologists revisited the site 40 years after the 1967 discovery, they found more skeletal fragments laying on the surface, which this time they photographed. Compounding this mystery is the absence of photographs or detailed drawings of the original discovery, despite the expedition being well-funded and professionally led, equipped with cameras and video technology. Why was such critical evidence not preserved? Was this an oversight by Leakey, a young but seasoned researcher, or a deliberate omission? If OMO-1 was indeed a surface find, as Butzer suggests, this suggests deliberate malice. Could Leakey have hidden the true nature of the find to bolster its significance, knowing a surface origin might cast doubt on its antiquity? The lack of visual records leaves us questioning the integrity of the discovery process, a gap that undermines confidence in subsequent age estimates. The absence of photographic or detailed documentary evidence from 1967 is a glaring omission for a well-funded expedition. It was common practice by that time for fossil finds to be photographed in their original position for the very reason that it is very important information. Leakey's leadership and the presence of advanced equipment suggest this was no amateur effort, yet no images exist to settle the in-situ debate. Was this a logistical failure, or did Leakey suppress evidence to protect the fossil's status? A surface find would diminish its scientific value, forcing reliance on indirect dating methods prone to error. The partially in situ claim by Leakey adds complexity. Did the skull remain embedded while the skeleton eroded out, or vice versa? Without specifics, we're left guessing, a frustrating gap for a find of such importance. As mentioned, the setting which OMO-1 was discovered is an ancient lakeshore from when Lake Turkana was much higher, around 6,000 to 9,000 years ago. Let's repeat that. OMO-1 was found on the shoreline of a lake dated to less than 10,000 years ago. If OMO-1 was 200,000 years old, That means that the fossil would have been buried under at least 50 meters of sediments over that time, and the lake washed away these sediments, magically revealing the relatively well-preserved fossil. What's more, although it is often claimed that no datable archaeological artifacts were found with Omo 1, in fact, as also noted by Butzer, there were 69 stone tools, a complete and butchered bovid skeleton, a complete flamingo skeleton, and just a few feet uphill from Omo 1 there were 5 bone harpoons. These bone harpoons have been directly dated to exactly 9,100 years ago. These dates are undisputed. All of this suggests an occupation site, as also noted by Butzer. If the Omo 1 site was an occupation site associated with a lake, then it is not 200,000 years old, it must be only 9,000 years old. As stated, Leakey obtained a single date of approximately 130,000 years for the Ethiopia reef mollusks, a figure he championed as fact for decades. However, Butzer cautioned that this date should not be considered too seriously as an age, due to open system behavior in mollusks where uranium leaching distorts results. This methodological critique raises a red flag. If the date is unreliable, why did it become the accepted age for Omo 1? The 130,000-year date that was cited as the age for Omo 1 from 1969 until the early 2000s was based on a test from a single shell that was considered to be highly dubious by the geologists who conducted the lab work. And yet the out-of-Africa theory was largely based on the dating of the Omo 1 discovery to at least 100,000 years ago. Let's just state this again. David Thurber, a geochronologist at Lamont Laboratory, likely processed this older date, but his absence from the credit for the shell labelled L1303J reflects his reluctance to endorse an uncertain result, as suggested by his own work on the limitations this type of dating. Indeed, the 130,000-year date is not included in any of Thurber's reports, which suggests he did not want to be credited with that date and that he warned Leakey and Butzer that the date should not be taken seriously. Nevertheless, the 130,000-year date gained traction in the 1980s, underpinning the out-of-Africa theory, which posits that modern humans originated in an African Garden of Eden and migrated globally. Chris Stringer and others relied on this fossil as evidence of early Homo sapiens, yet the dating issue, highlighted by Butzer's warning, seems to have been overlooked. But why? Was the allure of a single dramatic age estimate too compelling to question, especially when it fit the Leakey's narrative of human evolution? The plot thickens with recent dating of the fossil site to 196,000 and finally 233,000 years old. These advances have been framed as proving Omo 1 to be among the oldest Homo sapiens. But here's the catch. If Omo 1 was not in situ, as Butzer's surface find description implies, these dates tied to stratigraphic layers become irrelevant. A surface find's age cannot be reliably linked to surrounding sediments, rendering the estimate suspect. More likely, Omo 1 is merely a modern human who lived on the lakeshore around 9,000 years ago, and not an early modern human who lived some 200,000 years ago. The Kibish Formation's variable depositional environments, siltstones, tuffs and lake sediments, might preserve fossils differently, but the degree of difference strains credulity without further evidence. Could this comparison hint at deliberate misinformation by Leakey, who pushed the older date despite Butzer's reservations? The discrepancies surrounding Omo 1's discovery and dating have far-reaching implications. If it was a surface find, as Butzer asserts, the reliance on stratigraphic dating collapses. The out-of-Africa theory, heavily influenced by Omo 1, rests on shaky ground if its age is uncertain. Stringer's acceptance of the 130,000-year figure, despite methodological critiques, might reflect a bias towards supporting a single origin hypothesis. Why didn't Stringer and the British Natural History Museum where he worked demand more rigorous validation, especially with newer techniques available by the late 1980s? Butzer's 9,000-year dates for lake levels contrast sharply with Leakey's 130,000-year result, which Butzer dismissed as being completely unreliable. Thurber's reluctance to credit the date, given his expertise, supports this skepticism. Why did the scientific community cling to the 130,000-year figure for so long, despite so many warnings. Adding to the intrigue is a paradox revealed through comparisons with another nearby find. A skull discovered Frank Howell at a site called Pelvic Corner in 1967 in the Kibish Formation is dated to approximately 6,000 years old, consistent with Bootz's lake-level dates. This skull, along with several skeletal remains, including a partial pelvis and limb bones, is one that is not ever discussed in relation to OMO-1. However, when a 2002 study commissioned by Frank Howell and Michael Day looked at these two skulls under a high-power microscope, they found something incredible. They found the OMO-1 skull to be less degraded despite its purported age of 200,000 years. How can a fossil claimed to be nearly 200,000 years old appear better preserved than one only 6,000 years old? This anomaly begs scrutiny. Were environmental conditions so different that OMO-1's burial site preserved it exceptionally well, or does this suggest a younger age, aligning it closer to Pelvic Corner? Both fossils were found on the surface of a hillside that had been eroded by the lake. So why are the ages so different? The comparison raises questions. Were Howell, one of the leaders of the 1967 OMO expedition with Leakey, and Michael Day, who created the OMO-1 reconstruction with Chris Stringer in 1982, suspicious of Leakey's 130,000-year date? Comparing OMO-1 to the Pelvic Corner skull, a nearby and younger find, might have been a deliberate attempt to test its antiquity. If OMO-1's preservation matched or exceeded Pelvic Corner's, it would indicate either a preservation miracle or a dating error. Another interesting find from this study was that OMO-1 had suffered nutritional problems before death, which is something that is seen in women due to childbearing. Indeed, another recent study also found evidence that OMO-1 was a fully modern female, despite the fact that Stringer and Leakey refer to the fossil as the man from Kibish. This study is significant because it was found that the fossil matches almost exactly the people who live in the OMO-1 valley today. It has also been noted that one of the leg bones shows signs of crushing, which could have been caused by a crocodile attack. Is this how OMO-1 died? Whatever the case, the preservation paradox with the Pelvic Corner skull adds another layer. OMO-1's lesser degradation, despite a supposed age 20 to 40 times greater, defies expectation. Was it buried in an unusually protective environment? Or does this suggest a younger age, perhaps aligning with Pelvic Corner's 6,000 years? Howell and Day's study might reflect suspicion of Leakey's date, a quiet challenge to his narrative. Their detailed study contrasts with the 1967 silence. Did they seek to re-evaluate OMO-1's age through other evidence? The story of OMO-1 is a tale of how discovery, context, and dating methods shape our understanding of human origins. If Bootz's surface find description holds, the older dates must be disregarded, as they rely on stratigraphic integrity OMO-1 lacks. The 130,000-year date also stands on shaky ground due to Bootz's account. The preservation anomaly with Pelvic Corner further erodes confidence, hinting at possible misdating or exceptional preservation conditions unaccounted for. Without photographic evidence or a clear resolution of the in situ debate, OMO-1's status as the oldest Homo sapiens remains uncertain.